Okay, welcome back, students. We look at this question as we have an integral which looks very usual integral, and the question is whether this integral converges or diverges. We are still in section 7.8, and the first question is why this integral is improper. So I know that this integral is improper, and the reason why it's improper, let's look a little bit about this integral and this function. Now, look at this function. Where do we have a problem with this function? Where are the point of discontinuity for this function? 1 over x. So if you look at 1 over x, this is not defined at x equal to 0. It's clear if x is equal to 0, 1 over 0, so it is 1 over 0, it's a problem. So this function is not defined at 0. Now, ask yourself, is 0 from here to here? The answer is yes. Why it's yes? Because it's clearly we start from 0. We start from where I have a problem. And that's not good. So this integral is not a usual integral. Be careful. Why? Because the function is not defined at 0, and my interval, it contains the 0. So this is the improper integral of the second type, or type 2, which is, we call it unbounded function. Unbounded function, because we have a problem at one point. Now, how we are going to solve this question is what we did in the terms of infinity. Since I have a problem here, I just need to go away from the 0. If you go away from the 0, you will start with an a. Now, how much a? Since I'm starting from 0 and going up into 1, this a should be something between 0 and 1. So a, let me write down here, this one should be a little bit greater than 0. Why a little bit greater than 0? Because I'm just trying to avoid that I start from 0. So I need to start from something a little bit greater than 0. And if you translate this word into limit, this means I need to take the limit as a goes to 0, but is not exactly 0. It is a little bit greater than 0, so I think it will be 0 plus. Okay, and that's how we do the integral. Now, without the limit, this is an easy integral. I'm sure you all know what's the integral of 1 over x. It is ln absolute value of x. You evaluate it from a to 1, and then you take the limit. X goes to 0 plus. I'm sorry, not x, it's an a. We substitute 1, so it is ln of 1 minus ln of a. Now, if you look at this integral, direct substitution should give me ln of 1 is 0, ln of 0 plus, if you remember, this is negative infinity. But then there is a negative, so this is 0. Let me just write it down here so you don't forget what we are doing here. So this one, if we do direct substitution, we'll get 0 minus ln 0 plus, and this is negative infinity. So the final answer will be 0 plus infinity, and the final answer is just infinity. So the final answer is just infinity. And if we say the answer is infinity, it means the integral is diverges. And that's how we solve such an integral. Please, if you have any question, let me know and I will be happy to answer it. This is type 2, where the function is n-bounded.